Good afternoon all. So today I will be explaining about the designing of the SRE command center. Now the whole idea of this project is to create one system which allows the SREs, which is site reliability engineers, to monitor their applications. Not only monitor but also if any incident appears, then to efficiently manage and handle that incident. So the whole idea of this system is SREs usually use different set of monitoring tools, and those tools works on open telemetry. It creates logs, traces and different types of data. So what usually happens, these three things, logs, traces and metrics, get collects in one unit, and that units export these logs, metrics and traces to some kind of a dashboard, and using those dashboard SRE knows what is going through their systems. For example, if you take the example of Amazon, then in most of the cases it happens that Amazon has very high traffic at some point of time and very low traffic at some point of time. So in case of high traffic, there is a chance that one of the services of Amazon might go down. So how does Amazon knows that okay, this particular service at this particular of time was down? So what they do is they captures the logs, metrics or the traces of across the different microservices. They export those logs and traces and they check and in real time what is going wrong with their system. So that's the well established ecosystem. So what's the problem with it? To identify the problem we identified is usually the volume of logs, traces and metrics is very high. Imagine uh, millions of customers are using Amazons and each customer is generating thousands of logs and metrics and traces. Then the volume of data is very huge. So to identify the correct pinpoint across those logs, metrics and traces is a difficult challenge, but it's already solved. The next challenge is you have the logs, you have the metrics, you have the traces. How will you automatically solve this? Because if any microservices goes down, the error propagated to all the different services. So the role of production engineers kick in. He wakes up at 3 a.m. if anything happens, and he tries to manually identify what was wrong. He identified that part and he tried to fix it manually. So this is a very hassle and very big lag. But is there an efficient way to solve it? The answer is yes. In today's modern world, we use agentic AI to automate these processes. And what are the basic requirements of agentic AI? Lots of data which can handle the patterns, right? So do we have that data? Of course, we have the logs, metrics and traces. So how can we efficiently solve this problem? We can create one AI system which identifies patterns across these logs, metrics and traces, and then based on those patterns it will try to resolve those issue autonomously, and production engineer at the end will going to review it. Okay, is it solving it in the right approach or is it going in some kind of a wrong approach? So that's the whole idea of this current process. Now based on this idea we will design it. So to first design it, I have given you the very solid general overview. What is the problem, what we identified, what are the current solutions are already present, what they are lagging in. So let's kick into this designing part and let's understand this whole scenario in some more granular level. So the designing part we already covered. The designing objective is very simple. We have one big system. Its systems had lots of different microservices. Each microservices will export logs, metrics and traces. And based on these three things, we will identify failures, causes and some root analysis. Yeah, that's the whole idea. Now let's understand the needs of SRE. What SRE needs? First of all, alert fatigue is there. What is this alert fatigue? Alert fatigue is, suppose your server goes down, okay, and it's 3 a.m. So the production engineer or say SRE, they kick in. Okay, so they kicks in and try to resolve. That's the whole idea, right? So is it really necessary for them to be awake at the 3 a.m. and try to resolve this? No, it's not necessary in today's world because we have some better efficient alternatives. So this alert fatigue is okay. You have the alerts and you are saying okay, I need to pinpoint what's gone wrong, and that causes a lot of lag and lot of resistance. So that's an alert fatigue. Now what is the context switching? Okay, I have very large volume of logs, already large volume of logs, metrics and traces, and I need to find out, I need to jumble between this and find out what's exactly gone wrong. That's the context switching. Okay, is the UI unit goes down, okay, is the card service goes down, if the payment service goes down, if the product catalog goes down. That's the whole idea of context switching. What goes wrong, where goes wrong, and I need to follow the context. That's the whole problem. And the RCA, that is root cause analysis. Okay, my front end goes down because of the heavy traffic, the button was not working, due to that button not working, the payment was gone down. That's the whole root cause analysis. Which microservices affected which different microservices and part of my system. That's the whole RCA process. Then now defining the core user stories. What See, the word user stories just means identifying the problems, at least in our case. Okay, that's all. So basically an SRE says he wants to see the health of the services and SLO status. SLO status are they are not that important in our case. When an alert fires, yeah, see, it's a time series data, so you can check those alert fire. This is time series data. Yeah. Then during an incident, I want to trigger a rollback. Now what is rollback? Move to earlier version. Okay. Suppose I have WhatsApp and the earlier version was working fine. I drop some update, and due to update everything is causing an havoc. So what will I do? I will again roll back to the earlier version. That's why we get beta updates on software before launching the whole software, right? That's the whole idea. Move to earlier version. Yeah. Post to Slacks, this is just a communication platform. After an incident, what to do after an investigation? Find all related metrics, logs and user actions for the postmortem. Now the word postmortem is just doing the RCA analysis. Okay. Information architecture. So how's the journey, like for example, let's see, suppose an incident occurs. Incident occurred. So what I will do, I will first detect. How I will detect? Suppose my payment service is gone down for 3 hours and I wasn't able to receive any single payment in the last 3 hours. So okay, that's the thing which I have detected. But is it so? Is it the payment service really goes down, or some other services in the back end causing that issue? That's the detection phase. I will go through the logs of payment service, I will see where the service is propagating, and based on those propagations I will check, okay, this thing is going down. So that's the detection part. Now triage. Now this word triage, what is mean by triage? Okay, triage means the word I just used, it's a fancy term for propagation map. Suppose this is my payment service. In the backend it use authorization service, auth service, and then again it's also calls product catalog for identifies the prices of products, and this auth and product catalog both calls to front end. Okay, in case my bottleneck is here in this part, in this gRPC, my bottleneck is there. Okay, not a problem. But the payment service is failing due to this, right? Due to this gRPC, product catalog is failing. Due to product catalog, payment service is failing. Okay, so that's the huge issue. I am getting the logs for payment service, right? I am exporting the logs or Docker logs, anything from payment service. So what went wrong? So that's the triage. I will check the stack trace. Okay, due payment service is failing. Why? Because front end itself failed. Due to that front end, the product catalogs didn't appears on the website, and that's why the payment service failed. That's the triage. Then investigation means we try to correlate everything. So we have suppose triage. Now my triage shows which services failed. Basically a dependency maps of the services which failed. Now based on this triage, I will do the investigation. Now what is the root investigation? Why my front end failed? Suppose I have deployed it on one EC2 instance which has the capacity of 8 GB of RAMs. 8 GB RAMs EC2 instance is there, and due to this EC2 instance, um, and imagine altogether 30,000 users appeared on my systems randomly, and I wasn't able to handle those much systems. So front end got very high amount of load, greater than its P90 capacity or P95 capacity. These are just the metrics used to identify traffic. Okay, so that much huge load was on there. My front end crashed, the EC2 crashed, which on which my front end is. That's what happened in the front end. So this is my investigation, because I have the prior knowledge. So based on this investigation, I find out, okay, this was the root cause. So we identified the root cause by correlating the data. Now the resolution, how we are going to solve it. The low fidelity wireframes, like focusing on the structure. Suppose here a core layout and information. These two things important. So basically you have very big service Amazon, so it has different microservices for payment, for auth, then for login, then for product, everything. So this is my structure of Amazon. Now again, this all depends on some Redis services, some in backend, some AWS services, some depends on Lambda services. It all depends. So my whole architecture, how it is defined, how open telemetry logs and traces are actually wired together. These are my low fidelity wireframes. In simple terms, low fidelity wireframes, you can call it as on very granular level, the tech stack or the microservices which I have implemented, how I am integrating all those together and how they are working together. That's the whole idea of the low fidelity wireframes, a low level design which is working together and how it is wired together. All that's the low fidelity. So it contains global navigation, main content area, and contextual panels. Okay, then guiding the design principles. Now first importantly, what should be the design principles if we are creating these systems? First is we need a clarity, clear visual hierarchy. Okay, this fails due to this system was affected, it was affected for this much of time, so this rollbacks are happened, due to that these things are triggered. That's the clarity. Then context is king. Now we are trying to resolve everything in the end using LLM. Okay, we will discuss that part later, but what LLM requires? LLM requires a strong context, right? Now this thing is true in the case of developers, they also require strong context. So without those we cannot go ahead. So this is the important thing. Actionable insights. Okay, my payment service is failing. Why it is failing? Error 404, we don't know why. Is it actionable insight? No, it's not actionable insights. Actionable insight is payment service is failing. Why? Because the auth service is failing. Okay, from this insight I will going to check the auth service. This is the context, and this is the actionable insight. High fidelity prototype, like dashboards where we can check what is going wrong in just an executive level. Detect it based on those dashboards and respond a small action panel, maybe an UI, to ease things up. Rather writing a very complex bash file, create one UI. Try to you already have what have gone wrong. So based on those UI, you will take some actions, and in backend, those actions will translate it into the bash code. That's the response. Validation and feedback. Okay, I can see the logs, I can see the alert, I have the revert button. Okay, so what's missing here? A validation, a feedback. Okay, this is the error. Suppose something is going down, so I can come up with lots and lots of theories that due to this it might goes down. Are those theories enough to identify, okay, actually this was happened? No, we need to find out between hundreds of theories which theory was correct, because LLMs are tend to hallucinate. So at that time, to reinforce the LLM, some feedback loop is required from the senior production engineers or anyone who is knowledgeable in that area. So that's the feedback thing. That's great. What are the next step? Refine these things. How will you going to refine? High fidelity prototype. You will take feedback. Yeah, it's here. And edge cases. Componentize. This is the important thing. You have your final design. It's into very big chunks. So are you going to use it? No, you will chunk it. You will contain it into different components, one, two, three, four, five, six different components, and then you will use these components, because if the bigger chunk goes down, everything goes down, but the single chunks go down, all other chunks, they can distribute the load, they can distribute the damage. Hands off, like a detailed design specific spec sheet, the prototypes, the MVPs, everything, measures. You launch it, you have the design ready, you launch it, you create the MVP. Now you, how will you identify, is it good, is it bad? Basically you will go through, okay, these things are missing. Okay, generally when last time this error occurred, our production engineers are awake from 3 a.m. to 8 a.m. It's 5 hours, but using this AI system or feedback loop, the time dramatically shifted from 3 a.m. to just 4 a.m. 1 hour. So that's the MTTR, matter time to response, or say time to resolution, TTR. So it's a benchmark. So that those benchmarks are required in measures. So that's all. So we saw how the systems is going to work, how we're going to create the high level architecture. Now after creating the high level architecture, how we are putting everything together, we also understand the different frameworks and is designing this part. So I have presented the solid design for creating this system. We have also gone through every granular level with the very practical example in the context of Amazon. We have also checked the different terms. I have tried my best to explain every different terms which I know or I came across during this presentation. So that's all from my sides. Any questions are welcome. So thank you. That's all from my side.